will be discussing about azeotropes. So azeotropes are mixture of liquids. Okay, they are the mixture of liquids which boils at a constant temperature. Like a pure liquid, such that the distillate has the same composition as that of this liquid mixture. Then such mixtures will be known as what? Constant boiling mixtures or azeotropes. So here, if I have to say it in simple words, then these azeotropes are what? They are the mixture of two liquids. Okay. Now, whenever we have two liquids, we know that they will differ in their boiling point. Yes or no? Each liquid will have its own boiling point. But these azeotropes, okay, even though they are a mixture, they will be a mixture of two liquids. But now, at a certain temperature, both of them will start boiling and at certain composition. Okay, that means the composition of whatever you have in the liquid state and whatever molecules are going to the vapor phase, the composition of the vapor phase and the liquid phase will be same. Then such mixtures are known as what? Azeotropes or constant boiling mixtures. For example, we have water and ethyl alcohol mixture, C2H5OH. Okay. Now these two, you know, they differ in their boiling points. In their boiling points. Water has 373 Kelvin as its boiling point, and ethyl alcohol it has 351.5 Kelvin as its boiling point. Now, whenever these two liquids at a certain composition, say at composition around, say when ethyl alcohol is C2H5OH has say 95% approx, this is approx, and water is say 5% in the mixture. In the mixture, you have 95% of ethyl alcohol and water as 5% in that particular composition and at particular temperature. And the temperature, the mixture, these two mixtures, whenever the temperature is say 351.15 Kelvin, this you have to remember it, okay? At this particular temperature, what happens is, now say in the liquid state, now here you have say this C2H5OH as 95% of ethyl alcohol and say 5% of what? Water. And you are heating it, C2H5OH, and you are heating it at a temperature of what? At 351.15 Kelvin. Okay? Then what will happen? At this particular temperature, this mixture starts boiling. Okay? And the vapor that you obtain at this temperature from this composition of ethyl alcohol and water this vapor will also have 95% approx. This is approx value. Okay? This 95% of ethyl alcohol and 5% of what? 5% of this water molecule. From this, what we can say is, like, you know, fractional distillation. Fractional distillation is used for separating the mixture of liquids by making use of their differences in boiling point. But you can see that at this particular temperature, the composition of the liquid phase and also the vapor phase is exactly the same. This means that you will not be able to concentrate ethyl alcohol by heating it above 95% purity. Okay? So the ethyl alcohol that is obtained from sugars by distillation is a dilute solution. It cannot be concentrated beyond 95%. Hope this is clear now. Now let's discuss about types of azeotropes. Mainly we have two types of azeotropes. One is minimum boiling azeotropes, the other one is maximum boiling azeotropes. Now types of azeotropes. Types. The first one is minimum boiling azeotropes. Now this minimum boiling azeotropes are obtained. These are the liquids which show large deviation, large positive deviation from Raoult's law. So these are the liquids which show large positive deviation from Raoult's law. Okay, so you have to remember this. Minimum boiling azeotropes are those liquids which show large positive deviation from Raoult's law. So this particular mixture of liquid, that is azeotrope, will have its boiling point below either of the pure liquid. Like you saw in case of this ethyl alcohol and water. Ethyl alcohol, it has its boiling point at 351.5, and water, you know, it has boiling point at 373 Kelvin. But the mixture at this particular composition will start boiling at this particular temperature. That means the boiling point of this particular azeotrope will be lower than the pure component. Okay, and one more thing you have to remember is, since they are showing positive deviation from Raoult's law, the vapor pressure will be higher than any of the pure component. So let's discuss about the graph. How will you plot such as azeotropes with the help of a graph? So suppose you have this side water molecule, this side you have water at this axis, at this point, and here you have pure ethyl alcohol, C2H5OH. So as we come this side, what will happen? Mole fraction of water will increase, and as you go that side, the mole fraction of ethyl alcohol will increase. Now, it has this water molecule, say it has its boiling point at 373 Kelvin, and this is that point, and ethyl alcohol has its boiling point around, say, 351.5 Kelvin. Okay? At a particular composition, I told you the exact composition, say, at a particular composition, at which composition? Around 95, exactly it is 95.57. At this composition, you have 95.57% of ethyl alcohol, C2H5OH, and you have 4.43% of water molecule. So at this particular temperature, at this point, see, this temperature corresponds to the azeotrope's boiling point, that is 351.15 Kelvin. So 351.15 Kelvin. At this particular temperature, what happens is the liquid starts boiling. Not a liquid, the mixture of the liquid. So we have a graph showing the boiling point of this particular point. You can see that this point corresponds to the temperature and the composition at which this particular mixture of liquid starts boiling, and please look at it properly. This boiling point of this particular mixture of ethyl alcohol and water is lower than that of the boiling point of ethyl alcohol or that of the water molecule. So this is the type of graph that will show minimum boiling point azeotropes. These are minimum boiling azeotropes, and this is how you plot the graph. So at last, the conclusion is that pure liquid was boiling at a higher temperature. The another liquid was also boiling at a higher temperature, but the azeotropic mixture at a particular composition will have its boiling point lower than any of the pure components. Hope this is clear. Now let's discuss about maximum boiling azeotropes. Maximum boiling azeotrope is just the opposite of minimum boiling azeotropes. So from the name itself, we can make it out minimum and maximum. Now we are going to discuss about maximum boiling azeotropes. Example, here is HCl and water. So these two form azeotrope at a particular temperature and at a particular composition. Now minimum boiling azeotropes will be shown by those liquids, by those liquid mixture which show large negative deviation. Okay, will show large negative deviation from Raman's side. An example is given. Now let's plot the graph. How does the graph look like? Now here what you have HCl this side, and its boiling point is 188 Kelvin, and this side you have what? Water, and you know its boiling point is 373 Kelvin. Okay, and as you can decide mole fraction of HCl will increase, and as you go towards the left hand side, the mole fraction of water will increase. Now here what we have is at a particular composition, the composition of say around here. So let me rub this part. At certain composition, approximately somewhere here, at what composition? At a composition of 20.23 percentage of water molecule, of 20.23 percentage of HCl, and 79.77 percentage of water molecule. So at this particular composition, okay, what will happen is they will show its maximum boiling azeotropes. So this boiling point and its boiling point has to be joined, and you can see that at this particular temperature, this temperature corresponds to 381.6. So 381.6. At this particular temperature, what will happen? 381.6 temperature, and at this particular composition of HCl and water, now they will start boiling. Not below that. You can see from the graph, this boiling point of these two mixture is higher than the pure water or the boiling point of HCl. Therefore, this is known as what? Maximum boiling azeotrope. You have to remember the temperature at which this particular mixture of liquid boils and also at what composition. Okay, so here this type of maximum boiling azeotropes will be shown by those liquids mixture which show less negative deviations from Raoult's. That means the negative deviation means the vapor pressure will be lower than that of the pure components. Therefore, to reach at that particular vapor pressure of boiling point, its temperature has been placed at this particular temperature only. This particular mixture of liquid will start boiling. Therefore, these are known as what? Maximum boiling azeotropes. So, thank you.